So in this video we're going to look at families of functions, and basically what we're meant to look at here are functions that have parameters in them. So our parameters are our pronumerals like m and c in our y equals mx plus c, that when you change their values you change one of the properties of the graph. And so we know for y equals mx plus c that our m value can be any real number and our c value can be any real number. Some of the other sorts of parameters we've come across before are the k in an exponential function. I've got a k and an m here. And again, we'll define some values for k. So k can be any real number except for 0. And the reason that it can't be 0 is if k is 0, you get 0 times e to the x, which gives you y is equal to 0. The line y is equal to 0 is a horizontal line that sits on the line y is equal to 0, which is the x-axis. And that's not an exponential function, so it's not part of the families of the same type of function. And the same value for the same deal for m. I think there's one. No, that works. That should not be on there. Let me get rid of that. That should just be reals. Okay, so the use of parameters, the reason that we're looking at them is it gives us a way to actually describe the general features of different types of functions. And one of the ways that we can investigate this is using a slider on your CAS calculator. That allows you to change the value of the parameter and watch what happens on your screen. So let's have a look at some. So the example is for y equals mx plus 4, where m is greater than 0, so positive values for m here, positive gradients. Find the x-intercept and find the values of m for which the x-intercept is greater than minus 3. Okay, so we've got a whole heap of values for m that we can put in here that will allow us to have an x-intercept greater than minus 3. But anyway, let's first of all solve this thing to find the x-intercept. Now, when you're working with functions with parameters in it, just leave the m as a constant in your head and solve like normal. So to find the x-intercept, you let y equal to 0, so y is 0 in the equation y equals mx plus 4. Solve for x because you're looking for the x-intercept. Okay, so we need to solve for x. You need to keep that in mind and not get tricked into trying to solve for m. You're looking for a solution for x. And so our x-intercept is going to be a value in terms of m. And then what the next question asks us to do is to find values of m for which the x-intercept is greater than minus 3. And so our x-intercept we just found is this minus 4 over m. That's our x-intercept. So we literally write that formula and make it greater than minus 3. And then we solve for m. Now, you'll notice when I get to here, I need to divide both sides by minus 3. When you divide an inequality by a negative number, when you multiply or divide, you actually change the order of the inequality. Okay, so make sure that if you're multiplying or dividing by a negative number, oops, let me bring this over here, that you remember to swap the inequality. Okay, so the reason that that happens is that you can see with inequalities a less than b, they stay in the same position. So this describes the relationship between a and b. If we add a constant amount to both a and b, they both shift up and the order remains the same. So this symbol can remain the same. If we start with a and b and we double both of them, okay, they both move up in the same direction, but one moves up more than the other. But the relationship between the two stays the same. So if we start off with minus 4 and minus 2, if we multiply each of those by 2, we get minus 8. So the minus 4 goes to minus 8 and the minus 2 goes to minus 4, but the relationship is still the same. This one, the red one, is still smaller than the blue one. But if we change the value by multiplying it by -1, okay, so we had A and B, so we're going to let 3 be our A and 4 be our B. If we change these to -3 and -4 and put those on the number line, and here they are here, you can see that the blue one was less than the red one originally, but the red one is now less than the blue one. And so the inequality has changed with the two numbers. Because if we keep the 3 on the left-hand side like we've got it here, we've now got -3, and that is greater than, not less than, -4. Let's look at another example. So this example is for the family of functions with the rule f of x is this function here. State the maximum domain and then find the coordinates of the intersection point with the line y is equal to x. Alright, so for maximum domain we need to look at what restrictions we've got here. So the domain, when we have the square root of something, is whatever is under here has to be greater than or equal to 0. So this is our domain restriction. And we've got x plus 2k. So that means that our x plus 2k has to be greater than 0. And if we solve that for x, which is what we're looking for, solve it for x by subtracting 2k from both sides, and we end up with x is greater than or equal to -2k. So that is our restricted domain. For the second one, we need to find the coordinates of the intersection point. So what we're going to do is we're going to make the two lines y1 equal to y2. And I'm going to just take the expression parts of the two functions, make them equal to each other, which is what I've done down here. And now I'm going to solve that to find the intersection points. So square both sides to get rid of the square root, tidy it up, I've got a quadratic, and so to solve that quadratic, I'm going to use the quadratic formula, substitute into the quadratic formula, simplify it up, and to get a solution for the quadratic formula, I need the little bit underneath the square root sign to be greater than or equal to 0. And so I'm going to have a restriction on k here for particular k values. So this is, I'm only going to get solutions if k is 1/8 is greater than or equal to k. So k is less than or equal to 1/8. So this will be one of the restrictions I have for my answer. And so when I write my answer, when I write my answer as coordinate points, which is what I've done here, here's my x value, and then I just substituted, this is the x value and this is the y value. I just substituted my x values into the original equation to get my y values here. So you can see that this is the square root of x plus 2k. That square root sign there should go all the way across. All the way across. And that's the coordinates of my intersection point with my restriction for k. So this next question asks us to find the minimum value for y is equal to ax squared plus b. So we're actually looking for a minimum y value. Not the x value, but the minimum y value. So to do that, if we have a look at the sort of function that we've got a parabola here. So our minimum value for y is going to be the y coordinate of our turning point minimum. So that's what we're going to need to find. So to do that, we're going to need to find the derivative, let it equal to 0, so that it tells, and solve it. So that will give us our x value that gives us the minimum value, and then substitute it in. So here's one I prepared earlier. So we find the derivative of that equation, dy dx. We let it equal to 0 and then we solve for x. So that gives us, for our turning point, that gives us that our x value is minus b on 2a. Okay, but that's not the minimum value for y. What we need to do now is put that x value back into the original equation up here and then simplify it to find y. So there's our original equation. There's our x value substituted in. You can do some algebraic manipulations here to tidy it up, gather it all together, and end up with minus b squared on 4a. So our minimum value for y is minus b squared on 4a. That is our final answer. Oops. Come on. That's our final answer. And so we'll just put a box around it there. So the processes that you're using are the same. You're just having to work with a lot of algebra. Let's look at another example. So here's our next question, and this one's actually from a VCA exam paper. So the graphs of y equals mx plus c and y equals ax squared will intersect. Okay, sounds pretty easy. Will intersect if now we've got some parameters, restrictions on a and c. All right, so let's do this. To find the point of intersection, we let them equal to each other, rearrange it, get x by itself. So we have a quadratic equation here. So we're going to try and solve this thing using the quadratic formula. Just move this over so we can see. Using the quadratic formula. So substitute in your a, your b, which is minus m, and your c, which is c. And simplify it down. And now we're going to talk about restrictions. And so we're going to get some solutions if we have two things happening. Our first thing that we need to happen is that a can't be equal to 0. Otherwise we'll get 0 on the bottom, no solution, and the y value is 0. And secondly, we need what is in this square root here to be greater than or equal to 0 if we want them to intersect. Greater than or equal to 0. I'm just going to work with greater than at the minute and go from there. So we've got all greater than and less than's in our answer, so I'm just going to work with that. All right, so if we have m squared minus 4ac greater than 0, we're going to have some restrictions around the values that we can have for a and c. So if we rearrange this so that we've got our answers got a greater than and c greater than, so let's rearrange this and solve it for c. So if we're going to solve this thing for c, what we need to do is we need to divide both sides of this inequality here by minus 4a. So if we're dividing by minus 4a, we're going to need to change the sign. But if our a is a negative number, and some of those options we had before, a was less than 0, so a could be negative. So we're actually going to have to look at two different scenarios. One, if a is greater than 0, and then the second one, if a is less than 0. So let's start. If a is greater than 0, that will mean that negative 4 times a, which is a positive number, so a negative times by a positive is going to be a negative answer. And so what we get is we need to swap the direction of our inequality, and we'll get that c is greater than, less than m squared divided by negative 4a. If a is negative, then what we get is minus 4 times by a negative number, and that overall answer is positive. And so, because it's positive, the direction that we've got remains. And so we end up with c greater than m squared minus 4a. And so now we need to look at the two combinations that we've got for our answers here. So we've got if a is greater than 0, then c is less than that. And our other combination that we've got is if a is less than 0, then c has to be greater than m squared minus 4a. So when we look at our options for this, let me just zoom us back. There's the question there. And you go through and you check all of your answers. You'll see that option D is the correct option. It's from the 2015 exam paper, and only 37% of the students got this correct. At that rate, pretty much it would be a case of most students guessed. Some knew, most people would have guessed. But now you know, and now you'll get it correct too.